section C2 on the golden ratio. This can be found in your pickover book on page 112. So what is the golden ratio? In 1509, Lucia Pacioli was a close friend to Leonardo da Vinci, published a piece of work with dealing with this number that is widely known as the golden ratio. So the golden ratio is symbolized by phi, which you can see there. I've seen a couple different symbols for it or variations of that, but that was what I've seen most. And we frequently see that in mathematics. The proportion can be explained by dividing a line in two segments. The ratio of the whole segment to the longer part is the same ratio as the longer part to the shorter part, and I'll provide a couple visuals for that in a bit. The symbol and the meaning, professionally known as the Greek letter tau, which means to cut. And then in the 20th century, Mark Barr gave the ratio the name phi, which is the first Greek letter in the name Phidias. And Phidias is a famous Greek sculptor that was very famous. Okay, so here we have the visual of what the golden ratio is. So as you can see, the blue is A, the orange is B. So the ratio of A plus B, the whole segment, over the long part A, is going to be the same as the ratio of A, the blue part, over B, the short part. And then you always are going to get this number 1.618, and then the decimal goes on for a long ways, and then that equals 0.5 again. So next we have the golden rectangle. So if the sides of a rectangle are in the golden ratio, so they equal at 1.618, then the rectangle can be classified as a golden rectangle. So what a golden rectangle is a rectangle that can be split into a smaller golden rectangle as well as a square. And then from that smaller golden rectangle, we can repeat the process. So that can be cut into a square and a smaller rectangle and so on. And that can happen indefinitely, revealing many and many smaller golden rectangles. So the golden rectangle is the only rectangle where a square can be created, so that the remaining rectangle is similar to the original rectangle. And again here, to understand a little bit what I'm talking about, so on the left there you can see the whole thing is a rectangle, and then A would be the square, and then B would be the other golden rectangle. Here we have another visual. You see you have the whole rectangle, and then this part is the square of the original golden rectangle, and then here would be the rectangle that is similar. So then if we keep on going, like we said, this would be the square, then this is the golden rectangle. Then from this one, this is the square, this is the golden rectangle. And you can see that it just keeps going smaller and smaller and smaller. So now we have the eye of God, and that is referred to as where all the vertices meet of the golden rectangles. So you can see as it keeps getting smaller, it goes right there. So looking deeper into the eye, so as I said, as we connect all the vertices that we see in the golden rectangles, we can see that a logarithmic spiral forms. So as you guys see on that last picture there was a spiral. And so that's pretty cool, because we see logarithmic spirals all the time in our world. Seashells, animal horns, etc. And then here at the DougCraftFineArt.com, this was a link that I looked on, and it was very in-depth as far as golden rectangles. It showed a lot of different ideas, like talking about the symmetry between the square root of 5 and the golden rectangle, and deriving and calculating phi. Just a bunch of different